So today we're going to carry on with our geometry revision. Learning objective for today's lesson will be to revise perimeter and the area of two-dimensional shapes, and then look at surface area and volume of three-dimensional shapes. And this will help you in answering past paper questions on geometry. So for each of the following slides, there are questions involving 2D shapes and 3D shapes. I would like you, please, to answer every question on every slide. Now, if you're feeling confident about each question, then you can pause the recording straight away, answer the question, and then you can check that your answer is correct when I go through that question further on in that slide. If you're not quite as confident, if you're not quite sure, you can't remember how to do something, then you can watch me start off the question and you can pause it at any time when you think that you feel confident in answering it. Either way, at the end of the session, I would really like you to take a photograph and upload your answers. Send them off to me, please, so that I can see how you've got on. Please, can you make sure that you label the questions really carefully? Thank you. So to start with, perimeter of two-dimensional shape. Perimeter is like the fence around the outside of the shape, so the total distance around the edges that outline a shape. For question 1, this diagram represents an 11 by 6 cm rectangle. Calculate the perimeter of the rectangle. If you're confident, pause the recording now and have a go. If you're not so confident, just remember that a rectangle has two sides, opposite sides that are the same length. So actually we've got 11 centimetres here and 11 centimetres at the bottom, 6 centimetres on the right hand side and 6 centimetres on the left hand side. So we would add up all four sides and our answer would become 34 centimetres. Right, for question 2, this is a lot harder. If you're confident, pause the recording, have a go. So calculating the perimeter of this shape, we know that this is 10 centimetres at the top. We know down the left hand side is 19 centimetres, and we don't know the other four remaining sides. However, if we look, side A and side B, the green sides, would be a total of 10 centimetres because they're the same, they equal the same as that side. Same with C and D. C and D added together would be the same as 19 centimetres. So now we are in a position to calculate the perimeter. So A plus B would be 10 centimetres, C plus D would be 19 centimetres, and then we can add up all four sides to get our answer 58 centimetres. So although we don't know the individual sides, we knew that that one and that one would equal to that one. Okay, 58 centimetres, well done if you got that right. Now the perimeter of a circle is called the circumference. For question 3 and 4, we need to know the circumference formula, and that is pi d. Another way of writing that is 2 pi r, because radius is half the size of diameter. So 2 times the radius, in this case 4 times 2 would be 8, the diameter would be 8. So it makes sense that 2 pi r is the same as pi d. Give it a go for question 3 and 4, making sure that you answer both of your questions to one decimal place as it says in the question. Let's check your answers. So in this one here, radius was 4, so 2 lots of the radius would be 8, so it would be 8 times pi. Sometimes you're asked to leave your answer as an expression of pi. In this one it said to work it out to one decimal place, so that would be 25.1 centimetres. For question 4, there's our formula again. This time we've got the diameter, which is 9, so 9 lots of pi. 9 lots of pi are 28.3 to one decimal place. Area. Now the area of a 2D shape, these are the two-dimensional shapes that you will need to know. All other shapes can be made up from these shapes. Okay, so we've got rectangle, we should all know the area of the rectangle is length times width. Triangle, base times height, and that is perpendicular height, divided by 2. Another way of writing that is half times base times height. Base times height divided by 2. Parallelogram is this, if you imagine your two sloping sides of a parallelogram and you squash those up, it would become the same as a rectangle. So actually it is the same formula as a rectangle, but we need to make sure that we use the perpendicular height, not the length of the slopy sides. So the area of a parallelogram is the base times the perpendicular height. Trapezium, we need to know the lengths of the parallel sides for this one, so we add together the lengths of the parallel sides, divide it by 2, and then multiply by the perpendicular height. Another way of writing that is half times the two lengths of the parallel sides, A and B, and multiply that by the perpendicular height. And finally, the area of a circle is pi r squared. Now you will need to know these for the next slide, so you can either flick back to have a look when you're answering those questions, or you can write them down. Yeah, it's up to you. So for questions 5, 6, 7 and 8, have a go at all of those questions and then check your answers with me. Right, so question 5, area of a rectangle, length times width, 8 times 3, which is 24 centimetres squared. Remember, for area we use the measurement centimetres squared. The triangle, I've actually written this answer wrong, so please listen to my answer and don't look at the answer. I've put in the wrong numbers, I'm sorry. So base times height divided by 2, so this would be 6 multiplied by 8, which would give us 48, divided by 2, which would give us 24. So your answer here should be 24 centimetres squared. Question 7, area of parallelogram is the base times the perpendicular height. So in this case it would be 21, which is the base, times the perpendicular height, which is 9, to give us 189 centimetres squared. Now, most GCSE questions I've seen where they've asked you to work out the area of a parallelogram show the sloping side as well. Please don't be fooled, okay? Always use the perpendicular height. And finally, to the trapezium. So half the length of the two parallel sides multiplied by the perpendicular height. So we'd have 10 plus 15, which is 25, divided by 2, which is 12.5, multiplied by 7 will give us 87.5 centimetres squared. Again, super job if you got those right. Now, quite often in GCSE questions we will have shapes that we know how to find the area of put together. So a compound shape is when two or more shapes are put together. So here, when it says work out the area of this pentagon, we actually need to split that into shapes that we do know how to find the area of. So if I put a line here, I've now got two shapes. I've got a rectangle, I know I can find the area of a rectangle, and I've got a triangle, and I know I can find the area of a triangle. So I now find the areas out separately. A rectangle, length times width, 12 times 10, would give me an area of 120 centimetres squared. For the triangle, base times height divided by 2, I know that my base here is 10, and I also know that my height here is going to be 18 centimetres. Take away 12 centimetres will give me this height here. So I know my height will be 6 centimetres. Divided by 2 will give me a total of 30 centimetres squared. Finally, and this is why these types of questions are 3 or 4 point questions, I now need to add my rectangle and my triangle together to get the area of the compound shape. 120 plus 30 will give me 150 centimetres squared. Area of circle, we know from our formula sheet that we looked at earlier, is area equals to pi r squared. R is the radius, so here we just substitute our values. The radius would be 6 squared, which would be 36. Now it says here to give your answer in terms of pi and state its units. So our answer here will be 36 pi millimetres squared, because we're working in millimetres. And we would leave our answer just as that. If it asked us to work it out to a decimal place, we would then put in our calculator 36 multiplied by pi, and it would give our answer to be 90 something millimetres squared. Okay. Right, question 11. Work out the area of the semicircle. Pi r squared. Now we do need to look here, we've got the diameter given us here, so we need to know what the radius is. Radius is half of the diameter, so our radius would be 5. So we'll substitute our values in to get 5 squared is 25. 25 pi will give us 78.55 centimetres squared. Now we're not quite finished here because we've just found out the area of the circle, but we want to know the area of the semicircle, so yes, we need to divide it by 2 and we would get 39.28 centimetres squared. Again, super job if you got those right. Right, we're going to move on to volume. So volume is for when we have three-dimensional shapes. Now we do need to know our formula for the volume of a cuboid. This is the pink shape up here, or here, rectangular prism, and that's length times width times height. For the other shapes, we usually are given the formula in a GCSE question, and we're just asked to use that formula, but it is worth trying to remember as much as you can. For a prism, when we've got any shape that's got its where the cross the surface area here is the same all the way down the shape, that's what a prism is. Okay, so where if you cut the shape anywhere along, it would have the same area. For a prism, we find out the area of the flat side, and then we multiply it by the height of the shape. So let's go through some of these now. Question 12, find the volume of this cube, pause the recording, have a go at that now. Length times width times height. Yeah, hopefully you can all do that one. 5 times 5 times 5 is 125 centimetre cubed. Remember, for volume, we use cubed, centimetre cubed. So for the volume of a prism, here we've got a shape here that is the same, wherever you cut it along that shape, it would look the same. So the area of the cross section multiplied by the length. So we've got a bit of work to do here. First thing we need to do is to find out the area of the cross section. Well, I can split that up into two rectangles. I've got one rectangle here, which would be 15 times 8, which is 120. And then I've got one rectangle here, which would be 5 times by 4, because this is 12, this is 8, so this bit here would be 4. So 5 times 4, which is 20. 120 plus 20 will give me an area of 140 centimetres squared for this L shape here. Volume is that area multiplied by its length, and its length is 6 centimetres. So 140 times 6 will give me a volume of 840 centimetre cubed. Okay, a bit more work for that one. Right, volume of a pyramid and a sphere. So usually these are taken from exam questions here. So usually they will give you the volume of a pyramid, okay, which is 1/3 times the area of the base, that's the area of the base, times the perpendicular height. Now this one says it has a square base. Work out the volume of the pyramid. So we're just going to put the values into our formula. 1/3 times the area of the base. The area of the base is 17.2 squared, isn't it? 17.2 times 17.2. Times by the perpendicular height. Perpendicular height, we are told, is 24.4. Multiply all those together and we should come out with an answer of 2,406.2 centimetre cubed. So for our sphere, the volume of a sphere is 4/3 times pi times r cubed. So here, if we plug it into the formula, 4/3 times pi times 9.5 cubed. So notice on our diagram we've got a diameter of 19 centimetres, so the radius would be 9.5 centimetres. Okay, plug that in and we get an answer of 3,591.4 centimetre cubed. Volume of a cone, given here. Have a go at this question. Give your answer to one decimal place. So again, plugging it in, 1/3 times pi times the radius squared, which is 8, so times 8 squared, times the perpendicular height, so that's 15 centimetres, not 17 centimetres, would give us 1005.3 centimetres squared. Right, we're on to our final topic, which is surface area. So the surface area does involve a little bit more calculating. The surface area is all of the total areas of every face on your 3D shape. So for a cuboid, we have the top and the bottom, we have the side, and we have the front and the back. So when we work out the total surface area, we need to do it in steps. So we've got the top here would be 8 times 5 is 40 centimetres squared. And we've got the top and the bottom in blue, so we would have 2 lots of 40 centimetres squared. We'd have the 2 sides, the purpley pinky side. Well, we know that this is 7 by 5, so 7 by 5 is 35, and we know that we need 2 lots of that. Okay, for the, I would call it the side and the side, they put the front and back here. And then finally, we need the green. We've got 2 of those. We know that this is 8. We know that this is 7. 8 times 7 is 56. We need 2 lots of those for the left and the right hand side. So if we add up all of those, 2 lots of 40, 2 lots of 35, 2 lots of 56, we will get a grand total of 262 centimetres squared. So the surface area of the whole shape, surface area of that cuboid, would be 282 centimetres squared. Surface area of a prism. I'd like you to have a go at this, remembering you need to find out all of the sides of your prism. So pause the recording, have a go. Right, let's go through it. So the area of the front triangle here, 4 times 3 divided by 2 will give us 6 centimetres squared. Okay, we've got this side here. Area of the back triangle is the same, isn't it? So that will also be 6 centimetres squared. Area of the sloping side, that's this big bit here. 7 by 5 will be 35 centimetres squared. Area of the side, so the side is, if you imagine, at the back of here, okay, and that would be 7 centimetres this way, 4 centimetres this way, so 7 by 4, 28 centimetres squared. And finally, the area of the bottom, so the bottom is 3 by 7, if you imagine that shape at the bottom, would be 21 centimetres squared. Add it all together and we get a grand total of 96 centimetres squared. Super. Right, surface area of a cylinder. Now obviously here we've got to combine areas of rectangle and areas of circles, because we have got the top shape here and the bottom circle there, and then we've got the bit that wraps around over here. So the circumference of the circle, first of all, we need to know this, because we need to find out what the area of our wraparound bit is. So if we find out this length here, then we can put it into our rectangle here to work out the area. So we do pi d. Radius is 4, so diameter is 8, so 8 times pi would be our circumference of our yellow circle. So I can put that onto my diagram here for helping me work it out. Then we've got the areas of the circle, so the areas of the circle are pi r squared would be 16, so 16 pi would be the top blue circle and the bottom pink circle. On they go. So I've got my areas of my 2 circles. I need to find the area of this bit here that wraps around. Well, I know the height of that was 10 because it told me so here. So I'm going to do 10 times 8, which will give me 80 pi. Then I can add up all of those. So my total surface area is going to be 80 pi plus 16 pi plus 16 pi, which gives me 112 pi. And if I'm asked to work that out as an answer, I can put that into my calculator, 112 times pi, which will give me 351.68 centimetres squared. Surface area of a sphere. Now it tells us here the surface area of a sphere is 4 pi r squared. So all we need to do is to substitute the values that we know into that. Have a go. Right, so 4 times pi times the radius squared. The radius is 6, so that would be 36. Put it into our calculator, we'll get 144 pi, which will give us 452.4 centimetres cubed to 1 decimal place. That should be centimetres squared. I do apologise. Right, we've gone through all of those questions. Please upload your work to Google Classroom, and then we'll be ready to do some past paper questions on geometry next week. Well done.